Now we will see the 1A experiment, that is R and RC triggering of SCR. First we will see the working principle, then we will see the procedure. This is a simply a half-wave control rectifier which consists of only one SCR. The SCR gets pulse only during the positive off cycle of the input. So when the SCR is triggered during the positive off cycle of the input, the output has been cut. When the gate voltage, there is voltage across the RG, is just exceed the gate threshold voltage, the SCR starts conducting. The conducting point, that is the gate voltage that is equal to the gate threshold voltage point, has been changed by using the RG value. So for different values of RG, we can get the different firing angle so that the SCR output has been got. The output voltage has been measured using the CRO as well as the voltmeter. By voltmeter, we are actually directly measuring the average output voltage. From CRO, we are finding out the alpha value and VM value. From these two values, we are actually calculating the output voltage. And we are finally checking that both voltages are same or not. So first we will see then we will see the procedure. Initial conditions, that is the CRO should be isolated. That is, we are having a 3 to 2 pin plug point that has been connected before connecting it to the power supply. Then the second one is we have to check all the components are in good condition or not. Then first, the circuit connections are shown in the circuit diagram. The SPST switch is opened for R triggering. Then by varying the value of the RG, we are actually finding out the output voltage. It is measured using the voltmeter as well as using the CRO. Then by closing the SPST switch, the same procedure has been got. Now we will see the UJT triggering of SCR. First I will explain the circuit arrangement. See, in the left side we are actually having the pulse circuit. In the right side we are actually having the power circuit. The pulse circuit actually the gate circuit. So we are having a 230 volt bar 12-0 transformer and a single diode, that is a half-wave control rectifier, and a UJT and a transformer. On the right hand side we are actually having a power supply and the load resistance R and an SCR. The pulse to the SCR has been given from the pulse transformer, which is produced from where the pulse is produced from the UJT. Now we will see the working principle, how it works. So here you can see that a UJT is having emitter, base 2 and base 1 terminals. When the emitter to base 1 voltage just exceeds the peak point voltage of the UJT will produce a pulse. So for that we are actually having a capacitor. So when the capacitor voltage it just exceeds the VP, UJT will produce the pulse. That pulse output has been given to the gate of the SCR. So here in the pulse side, we are actually having a 1 SCR. So this is a simply half-wave controlled rectifier. So that pulse has been produced only during the positive off cycle of the input voltage. So that has been given to the SCR. So the SCR is actually going to have a half-wave controlled output. Now we will see the procedure. So first, by adjusting the value of the 1K part, that the capacitor voltage has been changed so that we will be going to have a different firing angle. The circuit connections are given as shown in the circuit diagram. By adjusting the 1K part, the firing angle is adjusted. The same thing, we are going to have two measuring units, that is directly we are measuring using the voltmeter, and firing angle and VM and time period has been measured in the CRO, and both voltage has been compared.